During the model building, you try different combinations of exposure variables or the predictors which you think are clinically and statistically most important um, to impact your outcome of interest or your response variable. So in here, we would like to see which one of the variables, let's open up our data set one more time, hot 2 data set. Okay, so we have a bunch of variables in this data set, right? Weight status and smoking and BP status and age and weight and so many others. So we want to see which of these variables are most significant for our outcome of interest, systolic blood pressure. So for those purposes, you might like to run your regression a number of times. Most of this process itself is quite manual, although you can build in some automation through SAS, but mainly you will be the person who will be determining which variables at the end are most relevant to the model. Okay, so let's add a few more variables to our model and see which ones are most significant both clinically and scientifically when it comes to systolic blood pressure. I'm gonna add, say, maybe weight status as our category, and among the continuous variable, maybe age at start. Okay, so now I have 5 variables included here, and in the model tab, I'm gonna go edit and I'm gonna add all of these variables and we'll just use two-way factorial. So now you see that because these are 5 variables, they can be interacted many ways. So we have now a whole lot of combinations which might be uh, impacting the outcome of interest, that is systolic blood pressure. Okay, so now our model is going to be very complicated. Let's run this model one time and then we'll come back and start tweaking it a little bit. Okay, and let's submit this code. Okay, so now look at our parameter estimates. There's a huge number of numbers that we have to now interpret. We see that the BMI with each unit increase, now the BMI has much lower impact on systolic blood pressure. It used to be 2 millimeters, now it is reduced to almost half, because many of the effects of BMI are through, say, weight, which of course is a kind of what we use the word collinearity. So there is a collinearity between BMI. So the weight status should anyway not be included when we have BMI included. One of them should be included. So otherwise, the impact of each of them will be kind of biting or taking away some impact of the other, and so on. Okay, when it comes to the sex, we see that females have now 27 millimeters, which is hugely a cut from the original, where we saw that female had like probably 2 or 3 millimeters of mercury lower. So that's a huge low. So uh, I know this is just the start of our model. We will be tweaking it along the way, but first and foremost, just look at the p-values. We see that a bunch of these p-values are just not significant. This is not significant. This is not significant. This is not significant. So first and foremost, I would like to kick all these values out which have no statistical significance. That at least we can do manually. So to do that, go to Selections tab, and on the Selections tab, I'm going to remove by backward elimination, and the default criteria will be 0.5%. I'm just gonna the 5% p-value is going to be the kickoff kicking out kind of a criteria. So I'm going to keep that one as my default, as my threshold. So let's submit the code and see what we get. Okay. Now you see that that table parameter estimates must be much smaller. So let me open it up in this. Okay. Okay. Now we have a much sleek model here. We see that only the ones which statistically significant impact on systolic blood pressure are included. All of them are statistically significant. But still, we see that with all these categories in, the impact of female is huge, almost 26 millimeters of mercury lower compared to males. But again, we see that BMI and age at start has a minimal effect. 0.02 millimeters of mercury, who cares? 0.08, even less than 0.1%. I'm not bothered about that kind of an impact. So I'm going to remove all of these out. Okay, that I can do manually. I'll go to my model again, and I'm just going to keep the ones which were most important. That was sex and BMI. I'm going to keep the rest of them for now. There will be too many back and forth before we come to our final conclusion, which variables are the most important. Let me see my model again. Okay, I'm going to kick all of these out. Select all of them and delete. Okay, and let's run our program one more time. Okay, one thing I would also like to do. Okay, so now this is a much better model. We see that BMI with each unit increase, the systolic blood pressure increases by 1.64, and compared to those with high cholesterol, we see that borderline and desirable both have lower systolic blood pressure. Age at start has very little effect, only 1 or even less than 1 millimeters of mercury. I'm going to keep it for now, but we might like to remove it with more trial and error methods. Okay, so when it comes to your paper, you have to have the 3 or 4 most important of your models, and then you create a table, something like the one. This is the one of my papers. We then provide all the models which you think are of relevance to your model, and you provide them in a table. First, mostly you provide the unadjusted impact of all those variables on your outcome, and then a simpler model, more complex model, even more complex model, and the most complex model comes at the end. And then in your discussion, then you advocate one of these models which you think is the most appropriate for your analysis. Okay, and you have to then provide all the arguments why you think that one model is superior to the others. But in a nutshell, you at least have to have like 4 or 5 models in your table included to make your reasoning, and that when you are advocating or you are trying to convince your peers that which factors are most important for their impact on the outcome of your interest. In here, my outcome of interest was in fact breast cancer survival, and I was looking at how race is impacting, black or white is impacting the survival, breast cancer survival. And I have a bunch of other variables included in that analysis. Okay, hope it gave you some idea how to build a model. Of course, there is a lot of effort included in that, and a lot of back and forth included, and nobody can really teach you how to build your models. It is through each respective project that you will be determining which models suits best to your analysis and your argument. Okay, see you in the next video.